Ever wanted to write a program for a quantum computer? I know, it sounds like something straight out of science fiction, but today, that's exactly what we're going to do. We're going to go on a little quest to write our very first quantum program. And this isn't just for physicists in some high-tech lab anymore. The tools to actually get started with quantum programming are out there for everyone, and you can run them right on your own machine. So over the next few minutes, we're going to walk through the whole process, step by step. You'll see exactly how to create your own piece of quantum magic, right from your own computer. Okay, let's dive in. Every great quest needs a goal, right? Ours is actually pretty simple, but it's also kind of profound. We're going to write a basic program that unlocks a truly mind-bending quantum phenomenon. And the best part? No prior experience needed, just a little bit of curiosity. The tool that makes all this possible is this really powerful framework from IBM called Qiskit. You can think of it like our spellbook. It's the language we're going to use to communicate our instructions to a quantum computer. All right, so before we start our quest, we've got to prepare our gear. And for us, that just means setting up our software environment, which, trust me, is way simpler than you might think. First things first, you'll need Python installed. If you don't have it, no big deal. Just head over to python.org. Once you've got that, the setup is literally just one command. Open up your terminal, type pip install Qkit, hit enter, and bam, you've just installed the entire library for our quantum adventure. Okay, our toolkit is officially ready. Now it's time to learn the words of power, the basic components that make up any quantum program, or, as we're calling it, our first quantum spell. So in the normal computing world, we work with bits, right? They can be a 0 or a 1. Simple. Well, in the quantum world, we have the qubit, and here's the crazy part. It's not just a 0 or a 1, it can be both at the same time. That's where all its incredible potential comes from. Next, we need to actually do something to that qubit. And for that, we use something called a gate. Don't let the name intimidate you. A gate is just a quantum instruction, a command that tells our qubit how to behave. And finally, after we've given our instruction, we need to see what happened. So we perform a measurement. This basically forces the qubit to give us a straight answer, collapsing all of its quantum weirdness into a classical result that we can actually read, a 0 or a 1. For our very first quantum spell, we're going to use a special instruction called the Hadamard gate. Now this gate is the key. It's what unlocks the truly weird and wonderful nature of quantum mechanics. Think about it like this. A classical bit is like a light switch. It's either on or it's off, 1 or 0. But the Hadamard gate puts our qubit into a state of superposition. It's a mix of both 0 and 1 at the exact same time. The best analogy is a spinning coin. It's both heads and tails right up until the moment it lands. That's the fundamental power of a qubit. So we've written our spell, take one qubit, hit it with a Hadamard gate, and then measure the result. Now it's time to see what actually happens when we cast this spell. See, because quantum mechanics is all about probability. Running our program just once won't tell us much. To really see the pattern underneath, we're going to use Qiskit's air simulator to run our circuit thousands of times, like in an instant. And here are the results. After all those runs, we see something pretty amazing. That qubit we put into superposition, when we measure it, it collapses into the state 0 about half the time, and the state 1 the other half. It's a perfect 50-50 split. A true random coin flip, governed by the laws of physics themselves. So, you've followed the steps, you've seen the bar chart, but what does it all really mean? What have you actually accomplished with this simple little piece of code? Well, this is way more than just a few lines of code. You've built a quantum circuit, you've created a superposition state, and you've witnessed true quantum probability in action. And this result, it's not just a cool party trick. Creating true, unpredictable randomness is incredibly important for things like cryptography, scientific modeling, and secure communications. With just that one command, you've harnessed a core principle of quantum mechanics to create perfect randomness. You have officially taken your first step into the larger, incredible world of quantum computing. The journey has only just begun. So the real question is, where are you going to go from here?